Hi everyone, welcome to Algorithmics. Today we are going to solve another problem based on the two pointers approach. Before we start, if you are new, I want you to subscribe to my channel and hit the bell icon so that you never miss any updates. Your help and support help me to create more content for you. So let's get started. So the problem is comparing strings containing backspaces. It is a medium to a hard level problem. So let's see how we can solve this problem. So the problem statement. Given two strings containing backspaces which are identified by hash character, check if the two strings are equal. Okay. So let's see with an example. String 1 is xy hash z and string 2 is xz hash hash. So what they mean is that is wherever there is a hash, we have to implement a backspace. And after all the backspaces are implemented in both the strings, we have to check if both the strings are equal. So let's see. For the string 1 xy hash z. Now since here the hash character is there, if I assume it as backspace, so after applying this, the character y here, this will be deleted. So the string 1 will be xz. And here for string 2, it is xz hash xzz hash. So after implementing the hash character or the backspace, so the final string will be xz. As this, since hash is a backspace, I shall delete the character z with that backspace. So only character left will be xz. And in string 1 the character left will be xz, so string 1 is equal to string 2, so I shall put it as true. Now suppose here for second example, string 2 xp hash and string 2 is xyz hash hash. So for string 1 the p will get deleted, so only x will remain. For string 2 there are two hashes, so that means we have two backspaces. So y and z will get deleted, so only x will remain. So string 1 is equal to string 2, so I shall output true. Even suppose if there is one more hash, then all these three characters will get deleted, but here x will remain. So string 1 is not equal to string 2, so I should output false in such cases. So now let us see how we can solve this problem. I hope you understood with example actually what we need to do. There is a string given. There are two strings given and with some hash character which represent the backspace. After implementing the backspaces, whatever the string is left in both the cases, we must compare them, and if those are equal, we must output true. If they are not equal, we must output false. Okay, so let's see how we can solve. One idea I have is that we can solve it using a stack similar to some postfix evaluation. That is, we go on pushing the characters into the stack, and if we encounter a hash, we pop the character which will be equal to like implementing the backspace. And once the complete string is traversed, we pop out from the stack and then compare the two strings. I hope you got the idea. That is, if first I'll push the, for let's say an example 2 here. First I'll push the x, then I'll push p. Why? Since I have encountered a hash, I shall pop p out. Now finally, since my whole string is evaluated, the content of stack is x. Now here for string 2, I'll push x, y and z, and since I'm having two hashes, I shall pop out 2, and finally the content of stack 2 is also x, right? So finally the contents of stack 1 and contents of stack 2 are same, so I shall output it as true. But the time complexity for this will be n plus m, and the space complexity will be big O of n plus m. Now one thing we can see, since the time complexity is linear, it is hard that we can let's optimize it further, because in any case we have to traverse both the string at least once. So time complexity cannot be optimized, but can we do something about the space complexity? Can we do it in the big O of one space? So that's the question we have to ask to ourselves. So the answer is yes, we can do something about it, and that is given by the two pointer approach. So I wanted to pause the video here and think of at least some possible approach which can be solved using the two pointers. Now, so I shall now move to the algorithm. Now I assume that you might have some approach with you. Now here is my approach. Let's see how two pointer approach can be used to solve this problem. The basic logic is here as I'm showing you. So first what we'll do, first we'll start scanning both the strings from right to left. That is, we shall start scanning the string from the end. Now once we now at each point we shall get the index of the next valid character by applying backspaces if any. This is the most important step. I shall show you what this actually means as we move ahead in the video. But let's get a brief overview of how I break down the problem. So first I shall start scanning from the end, and then I shall get the index of the valid characters by applying backspaces. Then later on I shall compare the characters or their if they are equal or not. And once we reach the end of the string, so the string matches. So that is the overview. That is, you start from scanning from the end, then you apply the backspaces and compare the characters, and if you reach till the end, then your string has been matched. Or if somewhere in the middle the character does not match, you can just break out. Now we'll see how you can apply the backspaces. This one. Now to apply the backspaces, what we can do is, see, while scanning the string, if we come across the hash character, we shall increment the count of the backspace. That is, in any given string, what we'll do, we will keep the track of number of backspaces or number of hashes we encounter. So while scanning the string, if we encounter a hash character, and one more thing is there, like why I am scanning from right to left, this one, why I am scanning from right to left but not from left to right, because since I have to implement a backspace, the backspace can be only implemented if I encounter it first. So whatever the character is that is previous to backspace, that will get deleted. So if I scan the string from the end, that would be easier to skip the character, right? So while scanning the string, if I encounter the hash character, so I shall increment the count of the backspace, right? Now if the current character is not the hash, but the count of my backspace is greater than 0, what does it means? If my current character is not hash, but count of my backspace is greater than 0, it means that previously while scanning the string, I have encountered the hashes, which tells me that there must be a backspace operation to be carried out. And now since that string is not hash, so this is the character, since that character is not hash, so this is the character which must be deleted, so I must skip it. And if the character is not hash and neither the count is greater than 0, I just do nothing. So I hope you understood this procedure, because this is the most important procedure in the code. So what I'm doing is, I'll repeat again. While scanning the string, if I come across the hash, that means if I come across a backspace, so what I'll do, I will increment the count of the backspace here. I'll increment the count of the backspace, right? If I come across a hash, so this is the first thing. Second thing, if while scanning, if I don't come across the hash, but my count is greater than 0, it means that previously I must have encountered some hash backspace, and that backspace is not used. So this character must be skipped. So once I skip the character, then I shall decrement the count of backspace. So this should be to decrement the count of backspace. So that is done. And if the character is even not the hash, and also the count is equal to 0, you can say, then I just do nothing. So this is the overall logic and view. Now I shall show how this algorithm can be applied to solve the problem. So with this example, now what I'm going to show, everything would be completely clear for you. So let us assume that my string A is xy hash z and my string B is xz z hash. So I write this in a tabular format, so that the upper row gives you the indices and the lower value. This is the string A, and the bottom row is the string B. So I will just recap you the algorithm. What I am doing, I shall scan from the end, then I shall get the valid index. How I shall get the valid index? This is the applying backspace procedure. This is the applying backspace procedure. So what I'm doing, if I am getting the hash, I shall decrement the index. I shall move ahead, and also I shall increment the backspace count. But if it is not hash, but my backspace count is greater than 0, I shall just decrement the index. It means that I am just keeping that character. If it is neither the hash nor the count is greater than 0, then what I am doing is, I am just returning the index here. I am just returning the index, and this procedure till when I shall execute, until my index is greater than 0, or if I return from the middle. And finally I will check if my characters are equal or not. So that's the case. Now let's see how I'll execute this problem. So at initially my index of A is 3 and my index of B is 3, right? Initially my index of A is 3 and my index of B is 3. Now I will first count my valid A and valid B. What does valid A and valid B say? It will give me the index of the next valid character here. So for this, I need to run this algorithm. First, for string A, let us see what I get the index of the valid character. Now, initially I am at Z, so I will check if it is a hash. No, it is not a hash. Now initially also the backspace count would be 0, and here I am getting the index as 3. So that will be passed to my get valid index function, right? So initially the backspace count is 0 and my index is 3. Now I'll check if my hash is there at this point. No, there is no hash, so I shall move to the next. If not hash, then is backspace count greater than 0? No, the count is also not greater than 0. So if neither of those things happen, I just return my index. So what I'm getting is, I'm getting valid A as 3. So since nothing is there, so this is the valid character, right? So that must be the part of my string. So I'm just outputting it. Now for string B, let us see. Now for string b, I'm again getting the index as 3 and backspace count is 0. Now let us check this. If the current character is hash, yes, for string b the current character is hash, yes. So what I'm doing, I shall increment the backspace count here. I shall increment the backspace count, and now I shall decrement the index. Why I shall decrement the index? Because now once I encountered this, now I shall move to this side. Now I shall move to this side, right? Once I have encountered the hash, I shall move to the next character. And now second one. Now I shall run the loop again. I'll check if it is hash character. No, it is not a hash character. But is the backspace count greater than 0? Yes, the backspace count is greater than 0 here. So what I shall do, I shall just decrement the index, and that is I shall move from 2 to 1. So actually what I'm doing is I am just skipping this character. So my index will become 1. Now I shall run my loop again. Now what I'm doing, I'm checking once more that is my character at index 1, is it a hash character? No, it is not a hash character. And then also I need to decrease the backspace count. Yes, I forgot in the last step. That is, if not hash but backspace count is greater than 0, then decrement the index and decrement the backspace count. This is also to be done, and decrement the backspace count. So backspace count is also not greater than 0, right? So what I am doing is I am just returning the index. So my valid b will be 1. So my currently this valid a is 3. So this is my this. So currently my valid a is this index, and my valid b is this index. So what I'll check, I'll just do this following checks. So these are the checks I'm going to do. So what are the checks? I'll see if I have reached to the end. No, I have not reached to the end. And also this, that is, if I have reached, this is the case for if both strings have reached the end. This is the case for if both strings have reached the end. Have they reached the end? So no, they have not reached the end. That is, if valid a is less than 0 and valid b is less than 0. No, because you check that is and, that is both string must come. But if any one of the string had reached the end earlier, it means that the string is not matching. So this is the thing you must know. Or so I shall return false, but even that case is not satisfied. And if I'll check if is the are both characters not equal? No, right now the both characters are equal, so I will just continue. So my now next index would be the valid a minus 1 and valid b minus 1. Why I'm doing minus 1? Because right now the character at index 1 and the character at index 3, both of them have been checked. So I can now easily move to the next index, that is this one for b, and for this one and to index 2 for a. Now I'll check again. Now right now my index a is 2 and my index b is 0, as you can see here. Right now I'm here for x, that is for character b I am at x, so my index b is 0, and for string a I am at this index 2, so my index of a is 2, right? So now, so let's start again. Now these values I shall pass to my now I shall check the next valid character for string a. Now right now my backspace count would be 0 and my index which I'm passing will be 2. Now I shall check if the current character is hash. Yes, it is hash. So what I'm doing, I'm incrementing my count and decrementing my index. Now I'm decrementing my index here. Now I shall move on to the next character. Is my current character hash? No, it is not hash, but my backspace count is greater than 0. So what I'm doing, I'm skipping this character by decrementing my index here. So I made my index to 0. Also, I shall decrement my backspace count, showing that the backspace has been consumed. Now I shall move to the next character. Right now, from 2 I went to 1, and from 1 I went to 0 here, because at 2 I encountered a hash, so I incremented the count. At 1 when I came, the it was not hash, but my backspace count was greater than 0, so I consumed it by skipping a character. Now right now my index is also 0 and my backspace count is also 0, so I shall just return the index. So my index, so my valid a will be index 0. Now for valid b, if you run this algorithm again, you would not encounter a backspace, nor the backspace count would get increased. So you will directly return the index, so that so the valid b will also give 0. Now we shall do the following checks. Is valid a less than 0 and valid b less than 0? No. Is valid a less than 0 or valid b less than 0? No. And are both characters different? No. The both characters at index 0 are same. So even this will return false. And since I have reached the end of the string, it is true, and it is true. So at the same time I can say that my string has been completely matched and the algorithm is over. So this was the perfect visualization for this following algorithm. I hope you understood the problem. It is as simple. You have to just implement the following step. You must scan from the end. You have to get the valid index. This is the most important part here. What first you must count the backspaces, and for the characters which do not show backspace, but the count of backspace is greater than 0, you decrement the index by skipping the characters and decrement the backspace count. If neither the backspace count is greater than 0 or not the character is a hash, you just return that index, and you must repeat this until the index is greater than 0 or you reach the end, and finally you check if both characters are equal or not. So this is the problem here, and I want you to solve this problem on LeetCode. I guess I forgot to mention the link here, but I shall surely mention it in the description section of this video. I want you to go on the LeetCode and solve this problem. I want you to pause this video and solve this problem and come back again. I have explained the algorithm. Now I just want you to implement it in your own programming language. Now I shall move to the solution. The solution is just step-by-step implementation of this. So it will be very easy for you. I'll show. First, what I'm taking is I'm taking the indices of both the strings, that is s and t. Now I shall run the loop for both the string, that is index one is until index 1 is greater than 0 and index 2 is greater than 0. That is index 1 will be for string s and index 2 will be for string t, right? Now what I'm doing, I'm getting the valid indices using the get next valid character function. For I1 I'm passing the string and the current index. For I2 I'm passing the string t and current index. So let us see how this function is executing. So what I'm doing here, I'm keeping the backspace count. Now while my index is greater than 0, what I'm doing, if I'm checking the string is hash. If my string is hash, I'm incrementing the backspace count and I'm decrementing my index, showing that this current character has been operated. Now if this is not a backspace count, but if it is not a backspace character but the count is greater than 0, what I'm doing, I'm decrementing the backspace count, showing that this my backspace has been consumed. Also I'm decrementing my index, that showing that this current character has been operated. If none of the cases execute, I am just breaking off the loop and finally I'm returning the index. So this is my get valid character function. Finally I'm doing some condition checks here. These checks are like, first I'm checking if there are end for the both the strings, so I'm using the and here. And is if it is for one of the strings, so that the string is not matched, so I'm returning the false. And if I'm also checking if the characters pointed by two indices are same, if they are not same, then I shall return the false. If nothing of this works, I shall move on to the next character by decrementing the index I1 minus 1 and I2 minus 1, and once the complete loop gets executed, I shall return true. So that's it for this problem. I hope you enjoyed this video, understood some new concept. If you have any doubt, do put them in the comment section. Do like and share this video. Your support will always help me to create more content like this. Now in the next video, that will be the final video for this two-pointer approach, I shall upload a document where you shall have the review problems for this, so that you can practice on your own. Thank you.